welcome to the ADF Architecture TV channel. My name's Chris Muir. I'm a product manager, indeed an ADF product manager based down in Perth, Australia. In today's episode of the ADF Architecture TV channel and the next coming episodes, I'd like to talk to you about task flow, data control scope and transaction options. Now, this set of options is one that I've been documenting for quite a while. Indeed, on the ADF Architecture Square website, and you can see the URL on the recording at the moment, on that website we have a white paper already dedicated to discussing these options. It's called the Task Flow Transaction Fundamentals paper, and there's a couple of demos to go along with that. But in recognizing the fact that some people, well, they'd rather not read a white paper, but would have maybe something like this, the ADF Architecture TV channel, to watch and learn from me talking about these options, that's what we thought we'd do here. We discover these and discuss these options in quite a lot of detail. So before talking about these task flow, data control scope and transaction options, which are obviously got to do with transactions, we really need to sit back and ask a more fundamental question, and that is, what is a transaction and why do we want them? Now at this point I can actually hear a number of you, the audience, actually scoffing at this and going, what's a transaction? Because you probably have a background in database development, maybe you come from Oracle Forms, you've been working with PL/SQL, and you already know what I'm going to actually tell you about here, what the details of a transaction are. But we need to cover it for people that maybe come from a Java background or have just started out in computing. Now, for the layman, a transaction might be something that you would consider to be like, well, let's say you go into a bank and you give some money over, and you might think that's a transaction. But from a computing perspective, and particularly a database perspective, a transaction is actually an entire set of work. A number of individual operations, well, you might call them individual transactions, but a number of individual operations where as a whole, as a unit of work, we either commit all the changes or we roll back all the changes, which is a choice we have. We can do it any time, or typically we do if we hit an error. Now, why do we want this concept, this more sophisticated concept of transactions, and why does it really apply to ADF? Well, if you think about if we have a number of operations that we're undertaking and we do hit an error, if we don't have this ability to roll back the whole transaction, we can actually leave data in a messy state. Imagine we're transferring money between two bank accounts. We're going to transfer $20 from my account and put $20 in your account. Now, the overall transaction requires two pieces of work, getting some money out of my account and putting some money in your account. And imagine we get the $20 out of my account, but then we hit an error before we actually put the money in your account. Now, if we'd been saving each operation as we went along, the problem is the money's already gone from my account, and even though it doesn't hit your account, well, where does it go? Now, if we had the ability to have transactions that support multiple operations and roll back, even though the money has been taken from my account, if we hit an error because we can't get the money into your account, the rollback will take us back to a scenario where the money is back in my account without any very much programming besides a rollback call on the programmer's part. And it's this feature that we really want in ADF systems as well, because predominantly we're working with Oracle databases, but transactions are a very important part of most enterprise scale systems. Another benefit we'd like to make use of in terms of transactions is the fact that while I'm working on a transaction, so maybe I'm transferring money around accounts, if you're working within the same computing system, you won't see the results of those transactions until I've either completed all the work and committed it or rolled back. So this leaves you isolated from any of the nebulous changes where maybe I'm in a state transition where I actually have taken the money out of my account and I'm putting it in your account, but I haven't quite got there yet. You really are only interested in the end result, and you will not see those until a commit or a rollback's occurred. And in case of a rollback, obviously you don't see anything at all. So this isolation feature is a very useful feature that we in turn want in our ADF applications. We don't want to confuse the other sessions or the other transactions underway about any changes done to the data until it's actually been finalized. Now, even if you are a database professional and you already knew about that definition of transactions, there's one feature of transactions that may not be necessarily obvious to you, and that's the concept of state management. If you think about it, that a transaction is multiple operations which you commit and roll back at the end of the transaction. The fact of the matter is as you add more operations to the transaction, You, the only user within that session or within that transaction, will see all the changes that you've made since the start of that transaction. So this is a form of state management, and indeed it's something that's familiar to ADF programmers. It's something that we also want because we have shopping cart type applications where users might add, for instance, clothes items to the shopping cart, and they haven't yet committed the shopping cart, so we need this sort of state management as well. So in the end, from transactions, ADF, we want this concept of state management, the ability to commit and roll back a unit of work. These are all features that are very useful to ADF applications, and in this set of episodes we're going to look at how the task load, data control scope and transaction options give these to you, and this is something that you need to factor into your ADF architecture design. This does raise, of course, the interesting question: what actually defines and implements transactions in ADF applications? Well, the simple answer there is that is the purpose and that is the responsibility of the data control. And most ADF programmers, even beginner ones, experts, will be familiar with the data control because you would have used the ADF business component data control for interacting with the Oracle database or other ANSI SQL compliant databases out there. Now, the data control itself is what implements the transactional controls and the APIs. So it deals with undertaking all the different operations, it deals with providing the commit and rollback functionality, and in addition it deals with the state management, which you could also think of as a caching solution. Now, typically in a normal application, one instance of a data control will be given to each user session such that they can undertake transactions to do whatever they need to do in the application, such as the shopping cart example that I gave. But it is possible to create ADF applications where you give each user, each session I should say, multiple instances of data controls such that they can have multiple transactions occurring. And this is a design consideration for your application. Not all applications will require this, but some will. Now, unfortunately, it's not as simple as all that because JDeveloper, or I should say ADF, just doesn't support one type of data control. There's actually multiple different types of data controls that ADF provides. Yes, there's the ADF Business Components Data Control, or what used to be called the JBO Data Control. There's even data controls for supporting EJB, JPA. We also have POJO data controls, RESTful or URL data controls, SOAP, Web Service Data Controls, and even custom data controls. Now, all these data controls are, as we were talking to the transaction facilities before, are designed to carry state, so they meet that requirement 100%. However, in terms of the concepts of transactions and committing and rollback all the operations, in terms of the APIs and what different facilities each data control type provides, that does differ. Now, with web services, when you interact with them, there's essentially no transaction. Everything's done straight away as soon as the operation's undertaken with that data control. So you can't roll back a transaction unless, for instance, in SOAP-based web services, there is some sort of a broader transactional support provided by the associated policies. But generally speaking, web service data controls aren't going to support transactions. It's all implicitly committed as you operate with the external web service. Now, ADF Business Components does support commits and rollbacks, and you can undertake a number of operations then explicitly called the commit and rollback operation. Now, notice that word explicit there. Okay, so the user is explicit, or the programmer on the behalf of the user is explicitly calling the commit or rollback operation. Now, it gets a little bit more tricky with EJB and JPAs, the specific data control for them. Now, EJB and JPA under the box, under the covers, does support explicit commits and rollbacks, but it also supports implicit commits and rollbacks. And that the difference being explicit, after a number of operations, the user or the programmer have to call commit or rollback. Now, for an implicit transaction support, every operation is committed instantaneously as it occurs. And this really goes back to the layman's description of transactions. But EJB and JPA is sophisticated enough to deal with them both. Okay, it can do implicit or explicit commits and rollbacks. However, the caveat I'm building up to here is unfortunately in the current releases of JDeveloper and ADF, so that's 11GR1, 11.1170, and 11GR2, 11.1240, the EJB JPA data control that we've implemented at this stage only supports implicit commits and rollbacks. Okay, so there's a fundamental limitation in the way we've implemented that. Now, if you don't need the full feature of transactions, the ability to commit and roll back operations, this won't mean anything to you, and it might actually make the programming model simpler. But if you do need that, this is a limitation that you need to be aware of. However, going back to ADF business components and the data control type, it does support explicit commits and rollbacks. In fact, that's the only type of transaction that it supports. You will undertake a number of operations on your underlying VOs and EOs, your view objects and any objects, and at the end, the programmer or on behalf of the user or the session will commit and roll back all those operations. Now, this is good to know. We now understand that the data controls are basically handling all the transaction fundamentals or the functionality that we're looking for. But it does bring up more interesting questions about how the data controls actually fit into the overall ADF architecture in order to, well, answer questions like this. If the transactions are logically mapped to navigating groups of web pages, and remember, when we design our applications, typically the user might go over multiple web pages in order to participate in an overall transaction, how do we map the data control transactions to these web page boundaries? In addition, if we need to support separate transactions per session, so this is the concept that one user or one session will have multiple transactions underway, how do we configure this with just one data control? Indeed, if our applications use multiple different data controls, is there the need to maybe commit and roll back them as a group so that the transaction spans multiple data control instances or the multiple data control types? And finally, if we actually create an application that uses ADF libraries with multiple data controls in each library, how at runtime do we combine these data controls that are separated by these modules such that they can combine into one instance and share state? The answer to these questions is in the relationship of data controls and the data control types to the bounded task flow. In 11G, the release of JDeveloper and ADF, the bounded task flow is a fundamental design point or design module of ADF applications, and the bounded task flow under the behavior tab or set of properties has options for interacting with data controls, specifically the data control scope option and the transactions options. Now, in the future episodes of the ADF Architecture TV channel, what we're going to do is, first of all, look at those data control scope options and make you understand how they work. We'll also look at a concept of the data control frame, which is very important for understanding the whole concept of how the transactions join together. It's a very useful concept for understanding the complexities that we will be describing in the next couple of episodes. Beyond that, in an additional episode, we'll then look at the bounded task flow transaction options, of which there are 4, and we'll be discussing how their different options, what combining different bounded task flows that have different transaction options, how they combine to change the way that transactions are controlled in your applications. So I hope you've enjoyed this very brief ADF Architecture TV episode today, and you will join us for the data control scope episode and the transaction options episode of bounded task flows, which will fill out some of the what I consider to be most powerful features of the ADF framework.